For centuries, we have sought to extend the possibilities of human-made aviation by emulating the flight of birds. From Leonardo da Vinci in the 15th century
to the Wright brothers who invented the first successful airplane, and even today's less successful attempts at flight. Hi, I'm Abdul Ghani.
And I'm Alex.
And we are part of a research team that developed the world's first autonomous soaring drone, inspired by birds' flight. So far, human-made flying machines have reached great heights, and now unmanned air vehicles, or as you might know them, drones, are creating new possibilities for flight.
Generally, drones have been reliant on propellers and motors to keep them airborne.
But we set out to develop a drone which uses much less energy. It was inspired by the birds that we observed soaring around and through the buildings of our campus.
Birds use air currents to help them soar, which means that they continue flying without flapping their wings. One of the air currents they're using is a type of updraft. This occurs when horizontally blowing winds hit an obstacle, like a building, and are forced upwards over the top of it.
Using this technique means that birds use less of their own energy for flying and are able to remain airborne for longer.
So we wanted to try applying this energy-saving flying technique to our UAV.
We used computer modeling to identify the passage of airflow through the built-up environment and find the areas where the updrafts are strongest.
And then we built a prototype out of foam, as it needs to be lightweight. This has wings but no propellers to test if we could fly the drone with just an updraft.
And then it was time for a flight test. This prototype does not have a motor, so it is launched by hand. It has an autopilot function with custom codes uploaded based on our research, so it can think like a bird to plan the flight path.
The wings catch the updrafts in the air to push the drone higher and maintain flight, using less energy, just like birds.
Our initial testing showed that autonomous soaring is possible, since we were able to fly for more than 10 minutes without a propeller.
Next, we hope to create a drone that incorporates another bird feature that helps them fly better: feathers. Birds use their feathered wings to balance themselves and maintain a steady flight. They can sense changes in airflow through their feathers.
They can anticipate and make slight adjustments to the wing positions to compensate for gusts and air disturbances, which means less turbulence and a smoother ride. So we will add sensors to the wings, which will function similar to birds to sense the airflow around the wings.
Our soaring UAV will have many potential uses in the future, including being able to be flown in cities and especially in windy areas like coastal regions where it can be used for shark spotting.
So by taking inspiration from birds, masters of the sky, we hope to develop an energy-saving flying machine.